We're being asked to find all the relative extrema and to use your second derivative test when it applies. So remember, the second derivative test is a backup. It's like a proof. So this problem is using everything you know about your first derivative and everything you know about your second derivative and putting them together. So we have to start out by finding our first derivative. So f prime is equal to 3x squared minus 18x plus 27. Then I want to simplify it because I do know I need to put it equal to 0 and solve. So we always simplify. 18 divided by 3, 6. Don't lose your negative. And then plus 27 divided by 3, 9. That's factorable. So we want to know what multiplies to 9, adds to a negative 6. Because this is a positive, it's either plus plus or minus minus. The signs have to match. I look at this negative 6 and I go, oh, look, they're both negative. So negative 3 and negative 3. So my first derivative, 3 times x minus 3 times x minus 3. And then our shorthand, three times x minus 3 squared. Okay, now notice the x minus 3 is showing up an even number of times. That's something you kind of want to put in your brain for, oh, let's hold on to this information because it will cause something to happen in your graph every time. So setting it equal to 0, remember I'm ignoring the 3 multiplying out front because it's not equal to 0, although it is part of the value of the derivative. X equals 3, but remember this was a double root. And so that's something important. Setting up my intervals, polynomials are perfect everywhere, so they have a domain of negative infinity to infinity. So negative infinity to 3, 3 to infinity. Now it's time to test it. Pick some easy number between negative infinity and 3, like 0. And I take it and I plug it back into my derivative. So I'm looking 0 minus 3, negative 3. Square it, you get positive. Positive times the 3, positive interval. Now, between 3 and infinity, something easy like 10. 10 minus 3 is 7. Square it, positive value times the 3, positive value. And that's because we had a double root. So notice nothing happened. Nothing changed in this. This shows me that I have a monotonic function. This may be a new word for you. So monotonic means never changing. So technically, this is a continuously increasing function. And I'll show you what it looks like when we get to the end. Okay, so second derivative is our next step because we want to find out, what's happening. And so using my first derivative, f prime, was 3 times x minus 3 squared. You could use either one of the forms of the derivative. We could have used the polynomial written one if that's a more comfortable way of deriving for you, but technically you should be good at everything. So either one of these would have been fine. I'm going to do the chain rule just to give you a little more experience with a variety of rules. So my second derivative, the 2 drops and multiplies times the 3. The exponent drops 1, so it's x minus 3 to the first power. The derivative of x is 1. Now notice how I wrote that out. I only did that for your benefit. Technically, if I'm deriving, I know automatically that this is 6 times x minus 3. Okay? So then setting the x minus 3 equal to 0. Notice it showed up an odd number of times. This this is going to give us more information. So x equals 3 is critical for the second derivative as well. And I have negative infinity to 3, 3 to infinity. Plugging it in to my second derivative, I have 0 minus 3 is a negative value times 6. That's a negative concavity. So we know that's concave down. Okay, then 3 to infinity, 10 minus 3, positive, times a positive 6. That's a positive interval. That's concave up. So what you're looking at is a function whose shape looks like that, like a cubic, because it's concave down, and then it turns concave up, and there are no relative extrema because it never turned around and went a different direction. It was continuously increasing, which is what we found out from the first derivative. And then the second derivative just helped us with the curvature of it. And so in this case, no relative extrema.